So let's do a little introduction on angles and their measure. In this, we're going to define angles in standard position, coterminal angles, classifying quadrants, and quadrantal angles. First, let's take a look at the parts of an angle. If two rays are drawn from a common vertex to form an angle, by common vertex, we're talking about that part right there. We call one ray the initial side and the other ray the terminal side. Positive angles, the rotation from initial to terminal side is in the counterclockwise direction. So this is an example of a positive angle. Negative angles, the rotation from initial to terminal side is in the clockwise direction. So this is an example of a negative angle. That's the initial side, and it goes around clockwise to the terminal side. Standard position, the vertex of an angle is at the origin of a coordinate system, and its initial side, which we just talked about, where it starts, coincides with the positive x-axis. So when we're sketching angles, we use an arrow to show direction. That way you'll know whether you're rotating clockwise or counterclockwise. Lowercase Greek letters such as theta, alpha, beta, gamma will often be used to denote angles. So that's when the angles are unknown. Next, we're going to classify angles. Angles are often classified according to the quadrant in which their terminal side lies in, so where the angle ends. If the terminal side lies on x or y axis, we say it is a quadrantal angle. 90, 180, 270, and 360 are all quadrantal angles. Let's take a closer look. So here we have an initial side of an angle being at 0. As we 90, you will see that we are in the first quadrant. As we rotate past 90 and before 180, you can see that we are in the second quadrant. As we rotate past 180 before 270, you'll see that we are in the third quadrant, and as we rotate past 270, we are in the fourth quadrant. You'll notice that 0 and 360 are at the same place. We'll have a term for that in a second. So please note, 0 degrees starts on the positive x-axis. That's what makes this standard position. We name the quadrants going counterclockwise every 90 degrees. So we name the quadrants in the positive direction. So we start at 0 and we go around naming the quadrants as such. If the angle is on the x or y axis, it's not in a quadrant, it's a quadrantal angle. So if we had 90 degrees and I asked you which quadrant is 90 degrees in, you would say it's not in a quadrant because it's a quadrantal angle. Now let's take a look at coterminal angles. Angles that have the same initial and terminal sides are coterminal. So let's break down the word coterminal. The co in coterminal, if you think about the English language, used in words such as co-captain or co-owner. Co basically means the same, and terminal, used in the English language, means end. When you say something is terminal, it means it has some end. So coterminal together means same end. So if two angles have the same end, if the terminal side has the same end, then you'd say that those two angles are coterminal. So to find coterminal angles, you're going to rotate either in the positive direction or the negative direction one full circle. Here's an example. Angle A, right there, is our original angle. If we rotate in the negative direction 360 degrees, we end up with a negative angle, beta, and it ends at the same place. So alpha and beta in that example are coterminal. Likewise, if alpha is my original angle and I rotate 360 degrees back to that point, I get that angle beta, the B angle. That is also coterminal. So whether you rotate in the positive direction or the negative direction, 360 degrees, then it is coterminal. If I can rotate once and be in the same place, if I rotate 2 times or 3 times, I'll still end up in the same place. So for this reason, you can add and subtract multiples of full circles. So multiples of 360 degrees will work. So here we want to find one positive and one negative angle that is coterminal with the following angles in standard position. So first we have 30 degrees. I need a positive and a negative that are basically coterminal with 30. So how do we do that? Well, to get the negative angle, we would subtract 360. So you would go 30 degrees minus 360 to give you negative 330. Now what does that look like? That's what it looks like. In the green there, we have the original 30 degrees. If we subtract 360, we end up with negative 330, which is in pink. Now if we want to get the positive coterminal angle, I would add 360. And if I add 360 to 30, I would get 390. So the answer to that question, one positive and one negative, well, the positive is 390 and the negative is negative 330. What if we're doing negative 55? Well, again, I would add 360 and I would subtract 360. When I add 360 to negative 55, I get 305. So that would be my positive coterminal angle. If I subtract 360, then I will end up with negative 415. So those are my two answers. My positive answer is if I added 360, and I would get a positive 305 as seen here. And if I subtracted 360, I would get negative 415. So that would be my negative coterminal and my positive coterminal. For 110, if we subtract 360, we will get a negative angle. We would get a negative 250 degrees. And if we added 360, we would get a positive 470. And they will all end at that point right there. Name the quadrant in which each angle lies. Alright, 50. What does 50 look like? 50 is between 0 and 90, so it's somewhere in there. So that would be in the first quadrant. 208. 208 would be past 180 and before 270, so it'd be somewhere over there, and that would be quadrant 3, because we're naming the quadrants 1, 2, 3, 4. Negative 75, you can either find the positive coterminal angle or move in the negative direction. If we move in the negative direction 75 degrees, we'll be over here, which is in the 4th quadrant. The other way to do this is to find the positive coterminal angle. So if we add 360 to negative 75, we get $285, which is a little bit past 270, which is in the 4th quadrant. For negative 540, if I'm not completely aware of where that is, I can find a positive coterminal angle. So I know I'm going to have to rotate more than once. So I'm going to add 720 to get that coterminal angle. So I'm going to do a positive 720 and a negative 540. And I get 180. Now, because 180 is on this line right here, it is not a quadrantal angle. So that is NA. Negative 540 is not in a quadrant, it's a quadrantal angle. 750, I would subtract so that I get a smaller number so that I know which quadrant it's in. So 750 minus 2 circles, which would be minus 720, would be 30 degrees, which I know is in quadrant 1. And then 175 is right before you get to 180, so that's in quadrant 2.